Hey everyone, and welcome. Today, we are cracking the code on a really common programming challenge, and it's all about finding common ground. Think of it like this. Let's say you and a friend both have a shopping list. How do you figure out which items are on both of your lists? That's the exact problem we're solving today. Just, instead of milk and eggs, we're going to be using numbers. So let's kick things off with our mission. We need to clearly define our goal. What we're looking for is what programmers call the intersection of two arrays. So what exactly is an intersection? Honestly, it's super simple. It's just a brand new list that contains only the numbers that show up in both of our original lists. It's the overlap, the stuff they share. Simple as that. Now, like any good challenge, we've got a couple of rules we have to follow. Rule number 1, our final answer can't have any duplicates. Even if the number 2 shows up 10 times in both lists, we only put it in our result once. And rule number 2, the order of the numbers in our answer, it doesn't matter one bit. Let's make this real with a couple of quick examples. In this first one, you can see the only number that's in both lists is 2. So our intersection is just 2. Easy enough. In the second example, both 4 and 9 are in both lists, so our output is 9, 4. And remember, 4, 9 would be just as correct because that order doesn't matter. Okay, so how are we going to solve this thing efficiently? Well, we're going to pull out a secret weapon from our programming toolkit. Let's talk about the incredible power of hash sets. A hash set is perfect for this mission because it has two superpowers. First, it automatically takes care of uniqueness for us. You literally can't put the same thing in twice. But its real magic is its speed. When you ask a hash set, hey, do you have the number 9? It doesn't have to search through a whole list. It just knows, almost instantly, where to look. It's like flipping directly to the S section in a phone book instead of reading every single name from the beginning. It's a game changer. All right, with our secret weapon ready to go, we can lay out our strategy, and trust me, it's a really elegant and efficient two-step plan. So here's the master plan. Step 1 is to record. We take our first list of numbers, and we just dump all of them into a hash set. That creates our unique record. Step 2 is to check. We just walk through our second list, one number at a time, and for each one, we ask our hash set, hey, have you seen this number before? That's it. Record, and then check. Theory is great, but let's actually see this plan in action. We're going to walk through that second example step by step to see exactly how this works. Okay, so here's our starting line. We've got our two lists, nums1 and nums2. We've also got an empty hash set, which will be our record keeper, and an empty list that's going to become our final answer. And now for step 1. We take every single number from our first list, that's 4, 9, and 5, and we just add them to our set. And boom, just like that, our record is created. Notice how it's just the unique numbers. All right, on to step 2. We start looking at our second list, nums2, and the very first number we see is a 9. And this brings us to the most important question. We ask our hash set, do you contain the number 9? And thanks to that instant lookup superpower we talked about, it can answer us in a flash. And the answer is yes. So 2 things happen here. First, we add 9 to our result list. Then, and this is a really clever trick, we remove 9 from our set. Why do we do that? Well, this makes sure that if we see another 9 later on, we won't add it to our result a second time. It keeps our answer unique. Okay, let's move on. The next number in our second list is 4. So we do the same thing all over again. Is the number 4 in our current set? You bet it is. So we add 4 to our result, and we remove it from the set. You can see our result list is getting bigger, and our set is getting smaller. Now we just have to check the rest of the numbers in nums2. We see another 9, but we already took 9 out of our set, so that's a no. Then we see an 8, which was never in our set to begin with, another no. And finally, another 4, but again, we already found it and removed it. So we're all out of matches. And there you have it. We've gone through every number, and our final result is 9, 4. Mission accomplished. We followed the rules perfectly. So that's how it works. But why is this considered such a great solution? Let's take a look at the final score. The reason this whole approach is so popular and so powerful comes down to one simple, awesome word: speed. And that speed has a technical name, which you see right here, ON plus M. Now, don't let the letters in parentheses scare you. This is something called big O notation, and it's just the standard way programmers talk about how efficient an algorithm is. And all that O of n plus m stuff really means is this.
We make one pass through the first list, that's the N part, to build our set, and we make one pass through the second list, that's the M, to do our checks. That's all. We only have to touch each item one time, which makes this solution ridiculously efficient, especially when you're dealing with huge lists.
You know, this whole thing really shows a core idea in programming, picking the right tool for the right job. So I'll leave you with a question to think about. Now that you have this powerful hash set tool in your belt, what other kinds of problems could you solve with it?